And also, let's do x equals t cubed minus 3t, and y is just the same thing as t cubed minus 3t squared. Okay. Solution. Now we have to go from the known to the unknown, right? So 1. What is dy dx? I need that formula, guys. So it's dy dt divided by dx dt. So I know I was given x equals t squared plus 1 and y equals, oh, my bad. I didn't write this guy correctly. That was y equals t squared plus t. Okay. So what is dx dt, guys? Differentiate x with respect to t, you have 2t. What is dy dt? Differentiate y with respect to t, you have 2t plus 1. All right. So what do we do? What is going to be dy dx? Dy dx is dy dt. So you have a 2t plus 1 divided by, what is dx dt? You have 2t. So if you need to break this guy down, this is just 1 plus 1 over 2t. Okay, that's the first part. Now the second part is asking us for the second derivative, okay? So, and what is this formula? It says d dt dy dx, all right, divided by the x dt. Now, what does this mean, guys? Okay, so this is d dt. What is dy dx? I already found it. It's 1 plus 1 over 2t. Now, the problem here is that once your first derivative is incorrect, then your second derivative is also going to be incorrect, guys. So you got to be careful, okay? Divided by, what is dx dt? I had 2t. Okay, so if you differentiate this guy, remember, you're just going to have negative 1 over 2t all squared divided by 2t. Got to put things together. So d squared y over dx squared is exactly going to be, we have a negative 1 over 2t squared, right? Multiplied by 1 over 2t. And that's going to be negative 1 over 4t cubed. Okay, so this is my second derivative. What about my first derivative, guys? The first derivative, where is it? Okay, so we had it here, dy dx, 1 plus 1 over 2t. All right, so but we're not done, guys. Okay, so we're not done. The next question was asking us, oh, find the values of t with which the curve is concave upward, right? So what is the condition for concave upward? When we say when this guy is strictly positive. Okay, so let's see. Under what condition is this guy going to be positive? And that's a question we need to answer right now. Okay, I have negative 1. Let's take a look at this guy. I need this guy, 1 over 4t cubed, to be positive. What is the condition of t? What happens, guys? This is a negative sign. Ordinarily, negative 1 over 4t cubed is less than 0. Okay, for positive t, because of this negative sign. However, I need it to be positive. That means this guy is bigger than 0 when t is less than 0. Now, how did I know? How did you get that, Professor? Okay, good, easy. All right, so picking a negative number, suppose t is negative 1. So think about -1 divided by 4 times -1. This is like -1 over -4, and that's 1/4. What kind of number is 1/4? Positive. But if t is a positive number, say t equals 1, 1 cube is still 1, and then you still have -1/4. -1/4 is a negative number. So this guy is concave up when this guy happens, but apparently the t has to be less than 0. That's the condition. Make sense, guys? Okay. So let's go to the second question. The second one had x equals t cubed minus 3t and y equals t cubed minus 3t squared. All right. So apparently we need our dy dx, and that's exactly dy dt divided by dx dt. What is dy dt? Let's see. Differentiate this guy with respect to t. You have a 3t squared minus 6t. What is dx dt? Differentiate this guy with respect to t. I have a 3t squared minus 3. Now you can put things together now, right? The y dx is just going to be 3t squared minus 6t divided by 3t squared minus 3. Now, sometimes you have to think about this. Can I simplify? You have to think about the possibilities of simplifying, or pretty much breaking things down. Okay, so would that be possible? So let's see. On the top, can I do some kind of simplification? Is it possible to achieve that? We'll see. You have a 3. It's common on the top, right? I'm just going to have a t squared minus 2t. What about the bottom? 3 is common on the bottom, so that's t squared minus 1. 3 takes off 3. So we have dy dx equals t squared minus 2t divided by t squared minus 1. Okay. Does this make sense, guys? All right. Take a look at it for a second, just to make sure everything is good. Okay. Now, if you want to even step it up a little bit now, if you need a second derivative, what do you do? Okay, so this is d squared y over dx squared, d dt of dy dx divided by dx dt. Sometimes it can be complicated, like in this case now, I have to use the quotient rule, okay? What was dx dt? That was 3t squared minus 3. Okay, so I hope you guys remember quotient rule. You keep the bottom, take derivative of the top. You have 2t minus 2. Minus, now you have a big parenthesis. You keep the top, take derivative of the bottom. You got 2t divided by the square of the bottom. All right, that's quotient rule. Let me put it right here. Quotient rule. Now you divide this guy by what you still have on the bottom. Okay, so let's see how far things can simplify. Let's see how far things can. Okay, so I have to foil this guy. So that way I have a 2t cubed. Okay, what about this guy? Minus 2t squared. What about this part? Negative 2t. What about this guy? You got a plus 2. minus, I have a big parenthesis. This guy, you have a 2t cubed. What about this guy? Minus 4t squared. This is going to be all divided by t squared minus 1 squared. And then you have a 3t squared minus 3. Let's see, can things cancel out? Yes. This guy takes off this guy. This is going to be, you have a negative times negative here. It's going to be positive, right? So divided by, you have a t squared minus 1 squared, 3t squared minus 3. Okay. The second derivative, guys. Negative 2t squared plus 2t squared plus 4t squared, you get a 2t squared minus 2t plus 2, all divided by t squared minus 1 squared, 3t squared minus 3. Okay. So let's now modify the question, guys. Let's say for what values of t is the guy, let's say for what value of t do we have? Okay. Okay, for what value of t, I'm just trying to modify it, step it up a little bit, is it either concave up or concave down? Remember, what is the condition for concave up? This guy has to be strictly positive. What values of t are going to make these guys positive? Okay, so that's what we really need to think about. And what values of t are going to make, now when you have a fraction like this, you have to deal with it case by case basis. All right, so let me start from the bottom. Let me write denominator. In the denominator, we have this guy. So I'm going to try to break it down so that you guys can get what is going on. This part, this guy is always going to be positive, right? So I don't have to bother about that guy. Because why is it going to be positive? Because you have a square here. And this square is going to be taking care of things. What about here? For any value of t, will this guy be positive too? Think about it, guys. If I give you t as a negative number, is this still going to be positive? Okay. If I say, suppose t equals, of course, t cannot be 0, because if you set t equals 0, there's a problem. If I give you a negative t, let's say t is negative 1. Is it going to be positive? You're going to have a 0. Okay, so what do we do? Now, this is what you do, guys. You write 3t squared minus 3. Suppose this guy is greater than 0. Because you need this guy to be positive. That's why we're putting this guy here. So this becomes 3t squared is bigger than 3. That means my t squared is bigger than 1. Okay, so that means your t has to be bigger than 1. Now, on the bottom, guys, this guy, this denominator is going to be greater than 0 if this guy is greater than 1. Okay, this part is already strictly greater than 0. So we only, because this part is strictly greater than 0 already, this is the only thing we have to deal with. And look at how I broke it down with this red. Now, case by case, remember, and then we'll combine things. So what about the numerator? The guy on the top, you have a 2t squared minus 2t plus 2. Now, under what condition, under what values of t will this guy be bigger than 0? That's my concern. I have to find a way to figure it out. Okay, so where do we go from there? Again, let me pick a red. I'm going to just do something like this, something very fancy. divide through by 2 because 2 is common. We're going to have a t squared minus t plus 1 greater than 0. Okay. Now, we have to take a look at this. I need this guy to be bigger than 0. What values of t will make this happen? Okay. Now, think about it, guys. What happens if t is greater than 1? Okay. All right. Let's see. If t is greater than 1, it is positive. Oh, good. But sometimes you don't want to go with the largest number. So let's see again. What value of t can I plug in here? And this guy is going to be positive. Let me think about a number such as, let's say 1/2. Okay. Remember, I'm just trying to, step this up a little bit. If t is 1/2, let's say if t is 1/2, okay, so I have a 1/4 minus 1/2 plus 1. Okay, so is this going to be a positive number? The answer is yes. It's going to be a positive number. Okay, looks like, okay, we're good. That looks like the top is good. 1/2. Now, let's assume that that's the best number you can get. Okay, so that's my assumption. Suppose that t equals 1/2 is the best you can get. So what's the next thing you do? The next thing you're going to do is, if the top is bigger than 0, if this guy is true, as a matter of fact, guys, if I decide to step this guy down a little bit, it can still work. If I use the 1/3, that can still be fine. Okay. So, but this guy is already this way. Now, that means that the numerator, think about it now. Okay, let's put things together. Now, when it is with fraction, you have to be very careful because things can be somewhat technical. So the numerator is greater than 0. We say if this guy is greater than 1/2. And we say the denominator is greater than 0 if this guy is bigger than 1. How can I bring things together? Think about it. Okay. So the way I can actually bring things together will be for the fact that to combine these two things to make sure that numerator divided by denominator stays positive, that means my t has to be larger than 1. If I pick anything lesser than 1, let's see, okay? Let's assume I pick t equals 1/2. Let's come back here, okay? I picked 1/2, right? So that way I have, let's see. Okay. So this is like 12/4. That means you have a negative 9/4. Then there's a problem. Okay. There's a problem. Whatever number you pick that is less than 1, it's going to make the denominator fail. But I need the top to be positive and the bottom to be positive. Right? So that's why this guy has to be bigger than 1. Makes sense, guys? I know you guys might have to, take a look at this again because you have to do it like on a step-by-step or case-by-case basis when you have a rational function. Okay, that was minus 2t plus 2. And then you have 3t squared minus 3. So this guy is greater than 0 if. So guys, you have to look for the best condition on t, okay? The best condition on t would help you out. Now, if I want to put this guy in interval form, that means I have to say that my t has to be a member of 1, comma. Remember this from Calc 1? Yes, exactly. Okay. So now let's look at another example. Okay, so let's use the same example. Let's use the second guy was about okay. So let's use the second. Find, let me say, find the points on the curve where the tangents is horizontal or vertical. Okay, so let's X okay, so solution. Now remember we said horizontal tangent, we called it HT. We say for horizontal tangent, guys, what is the possibility? What's the definition? We say dy dt has to be 0, but this guy has to be non-zero. What about vertical tangent? We say this guy has to be 0, and this guy has to be different from 0. Okay. So either ways, I need my first derivative, right? 3t squared minus 3, and then divide it. This is the xt, my bad. Okay. Either ways, I need this guy. So let's deal with the horizontal tangent first. It says that this guy has to be 0, right? And this guy has to be non-zero. So that means I have to set this guy to be 0. 3t, so set this guy to be 0. So what does that mean, guys? What is common? 3t is common, so I have a t minus 2 equals 0. Now, how do you deal with this guy? You say 3t equals either this guy is 0 or this guy is 0, right? So what does this tell me about my t? My t is 0 or 2. Okay. But the job is not done, guys. The job is not done. Now, when t equals 0, you got to plug it back into the equation. Okay. When t equals 0, remember, y was equal to t cubed minus 3t squared, and x was equal to t cubed minus 3t. When t equals 0, what is the value of x? X is 0 cubed minus 3 times 0, which is 0. Y is 0 cubed minus 3 times 0 squared, and that is also 0. So that means you have your first pair, 0, 0. Okay, so the second thing was yt equals 2. You do the same thing, guys. X equals 2 cubed minus 3 times 2. And that's 8 minus 6. And that's exactly what, guys? 2. Y is going to be a 2 cubed minus 3 times 2 squared. So you do have an 8 minus 12. And this is exactly what, guys? -4. So what is the pair here, guys? 2, -4. Okay. Makes sense, guys. So what does that mean? That tells you about the horizontal tangent. Okay. So that means horizontal tangents at 0, 0 and 2, -4. So you must get the pair. You must get the x and y pair back. All right. So what about the vertical tangent? I must set the x, the t, to be 0. And in this case, when we differentiated differentiated x with respect to t, the x, the t was actually what, guys? 3t squared minus 3. Set this guy equal to 0. I do have this guy. T squared minus 1 equals 0. Amazing. So now can I, this is difference of, you can actually have this in tools. When this happens, guys, how do we handle it? Say t plus 1 equals 0, or what? T minus 1 equals 0. So that means my t is a negative 1, or my t is 1. The same thing, guys. The same thing, okay? So you just come and say when t equals negative 1. Now, what was the question again? X is t cubed minus 3t, right? And then y was t cubed minus 3t squared. You got to plug it in. So what would be your x? Negative 1 cubed minus 3 times negative 1. What would this give you? This will give you 2. Y is negative 1 cubed minus 3 times negative 1 squared. What would this give you? Negative 4. So what is the pair here? The pair is 2, negative 4. Okay, so then the other guy, when t equals 1, you got to do the same thing. 1 cubed minus 3 times 1. And this is what? Negative 2. What about y? You have a 1 cubed minus 3 times 1 squared. And this is what? Negative 2. So what's the pair here, guys? Negative 2, negative 2. Now, what do we conclude? We say the vertical tangents at 2, negative 4 and negative 2, negative 2. So this is nice and smooth, right? Nice and easy. But of course, there are some times when you don't have horizontal tangents, or when you don't have like a vertical tangent. It depends on the function. For an exponential function now, for instance, so another example, suppose dy dt is like e to the t, and I want to find the horizontal tangent, right? Let's claim that this guy is non-zero, okay? What do? You set dy dt equals 0, right? So that means you're doing this guy equals 0. Is this ever possible, guys? Can an exponential function be equal to 0? Never. Okay. So why? Because this guy is always strictly positive. You can check, just do e to the negative 100, e to the 2, whatever. It's always going to be positive. So that means in this case, we just say no horizontal tangent. Make sense, guys? For all values of t. It's just going to be strictly positive. Strictly, very strictly positive. Okay. All right, so let's go another example. Curve C is actually defined by the parametric equations. X equals t squared, y equals t cubed minus 3t. The first question is this: find. Gotta find the tangents at the point 3, 0. And the second question is this: find the points on the curve C where the tangent is horizontal or vertical. And then, guys, we're going to wrap it up with to determine, okay, we're going to wrap up this question by determining where the curve is concave up or concave down. Okay, let's go. Solution. Now we need to find the tangent, right, when that happens. Okay, let's see. Okay, so A, what does that mean? I need to find dy dx. That's what it means by find the tangent, because this is not horizontal tangent, it's just says tangent. So, and this guy by formula, differentiate y, let's go up a little bit. Differentiate y with respect to t. What do you get? You get a 3t squared minus 3. Differentiate x with respect to t, you get a 2t. Okay, so that's your dy dx. We have that already. Now, but it gives us a point. It says at this point. What does that mean? Now, this first guy, you know, this is x and y pair. This guy corresponds to x. This guy corresponds to y. So, and this is your x. So since x is t squared, right? And we are given the point 3, 0. What does that mean, guys? It means that x is t squared. But what is x here, guys? X is 3, right? Equals 3. So we just find t. Okay, so why is this important? Because we really need to do some form of plugging in to find the slope. So this means that your t, we need to find our t, right? Plus or minus square root of 3. Okay, so but we're not done. When t equals, let's start with positive parts. What is your dy dx? Just plug it in, right? This is 3 times this guy over, this is 2 and square root of 3. If you do the math, you have square root of 3 squared, you have 3. 3 times 3, you have 9. 9 minus 3 divided by 2 root 3. This is like on the top, you have a 6 divided by 2 root 3. And this is like 3 divided by root 3. By rationalizing, you get square root of 3. So what is this square root of 3? Again, guys, this is the slope. Remember slope, guys. Okay. And the same thing you did for the positive square root of 3, you do it for the negative guy. The y dx is going to be 3 negative square root of 3 squared minus 3, all divided by 2 times negative square root of 3. This is exactly the same thing except for the fact that you have a negative here. So you just have a negative square root of 3. Again, this is still a slope. Right? Okay, so let me hold up a second and just scroll up and see, you know, so that you follow. Okay. Can we go on, guys? Okay. Okay. Let's move on, guys. So now we had when t is square root of 3, we had this was the slope, right? When t is this guy, this was the slope. Now, do you guys remember the equation of a line y equals mx plus c? Do you guys remember that? Okay. What's the m? The m is what we call the slope. The c is what we call the intercept, right? And then we had the same equation of a line. We had like this y minus y1, the 1-point form, x minus x1. Do you guys remember this as well? Okay. So now we need these equations. Remember, we were given, what point were we given? 3, 0. Okay. So we had, what are the slopes we have? Slopes. We had square root of 3 slope and negative square root of 3 slope. Now, so corresponding to this first part, what is going to be the equation? This is x1, this is y1. So y minus, what is y1, guys? 0. What is m, which is the slope? This first guy, we pick the first slope because we're corresponding it with this guy. 3 x minus, what is x1? 3. You have y equals square root of 3x minus 3 root 3. That's the first equation. And this is when t is a square root of 3. Now remember, what are we doing here, guys? It's more like we're finding the Cartesian equation where we are eliminating parameter t. Okay, so what about to this? Let me use the red now. So to this guy, what about its own equation? Okay, so we have 3, 0 and slope of negative square root of 3. Okay, so just took that off so that it will not be confusing. Y, this is, of course, again, this is x1, this is y1. Y minus 0 equals, what is the slope? Negative square root of 3, x minus 3. Almost the same thing, guys, except for the negative sign here in this case. Okay, and that's the first part. Those are the equations we need to generate. Make sense? You see how we did it from the idea of I need to know the dy dx. Okay, so once I know the dy dx, I'm going to find my slope. Okay, so once I get the slope, then I can talk about the equations. Make sense, guys? Now let's go to the second part of the question. It was asking us for the ht or the vt. Now, when we remember, guys, how do we get the horizontal tangent? And how do we get the vertical tangent? So for horizontal tangent, remember, you have to set dy dt to be 0. Of course, this guy has to be non-zero at this point. So when we did this guy, the first derivative was 3t squared minus 3. Set it equal to 0. Equals 0. And that means that what? You have a t squared minus 1 equals 0. And this means that t is 1 and negative 1. But we're not done, guys. We're talking about the horizontal tangent here. Okay. So when t equals 1, Now you're going to plug t equals 1 back into the original functions given. Okay, you had x to be t squared minus, x was t squared, yes. And then let me just back up them. Y was t cubed minus 3t. When t is 1, you plug it back in these guys. X is going to be 1 squared, which is 1. Y is going to be a 1 cubed minus 3 times 1. 1 minus 3, and this is negative 2. So what's the pair here, guys? 1 comma negative 2. Okay, so when t is negative 1, you do the same thing. Negative 1 squared, which is 1. What about your y? You have a negative 1 cube, guys, minus 3 times negative 1. Make sense? Just plug it in. Negative 1 plus 3. And this is what, guys? 2. So what is the pair here? The pair is 1 comma 2. What's our conclusion? Amazing. Okay, so horizontal tangents at what, guys? 1 comma negative 2 and 1 comma 2. Cool, right? Cool. All right, so what about vertical tangents? So for vertical tangents, we set dx dt to be 0. And we say that this guy has to be non-zero. Okay. So what was our dx dt? That was just 2t. Set this guy equal to 0. This is the easiest, guys. T is just 0. So you do the same thing, plug it back into the original guy. So when t is 0, x is just 0 squared, and that's 0. Y is just going to be 0 cubed minus 3 times 0, and that's still 0. What's the pair here, guys? 0 comma 0. So how do we conclude? We say vertical tangents at 0 comma 0. Is it making sense now, guys? So the last part, we want to determine concave up or concave down. All right. So this is where we need some kind of, the first one we did, you know, we see how we did the analysis. So even in this case too, we're going to do something similar. Okay. We're going to do such similar analysis. So this is second derivative, right? So what's the formula? D dt of dy dx divided by d dt. I mean, that's not correct. Okay. So the one on the bottom doesn't have d dt. That's just dx dt. Cool. So differentiate with respect to t. Okay, so let's just back up a little bit, guys. Sorry, I have to just scroll on your face. What was dy dx? Oh, that was 3t squared minus 3 divided by 2t. So let's pick up that guy. That was 3t squared minus 3 divided by 2t. What was dx dt? Just 2t. Okay. So this guy, I can even just simplify this guy since it's not so complicated. That's just like 3 over 2t minus 3 over 2t, something like this. Now, what did I do, guys? No big deal. This is just 3t squared over 2t minus 3 over 2t. T takes off t. So when you differentiate that guy, what do you get? We're just going to get a 3t squared plus 3 all over 2. It's going to be 4t cubed. Why? That's just because if you differentiate this guy, you will get a 3t squared plus 3 divided by 2t squared. and then you still have 1 over 2t on the bottom. Okay, everything is justifiable, guys. So it's not some kind of magic, okay? So let's get down to it, guys. What's the condition for concave up? For concave up, we say this guy has to be strictly positive. And what values of t will make that happen? Okay. For what values of t will that happen? So the same way you have to analyze the top and the bottom. So the numerator is 3t squared plus 3. Right? I need this guy to be bigger than 0. The denominator is 4t cubed. Now, if this guy is bigger than 0, what does it mean? That means that my t cube is bigger than 0. That means that my t has to be bigger than 0. Cool. Cool. Okay. This guy has to be bigger than 0. In this case, for what value of t will this guy be bigger than 0? Think about it. So you have this guy. This t squared plus 1 bigger than 0. Okay. So if you look at it, this has to be the condition. Because if I even go further right here, let me show you guys. So there's no magic. If you think about this, when t plus 1, okay, let me use it right. Think about this, guys. If t plus 1 equals 0, that means t is negative 1. If t minus 1 equals 0, that means t is 1, right? If t equals negative 1, plug in negative 1 here, there's a problem. Because negative 1 cubed is negative. So that means, oh, this is going to be a negative number. And we don't want that. When t equals 1, it's going to be positive. But which one is the smaller number? Is t greater than 0. So that means that this guy, when t is greater than 0. Okay, so the very basic intuitive idea. So what about concave down? For concave down, this guy has to be less than 0. And we had 3t squared plus 3 over 4t cubed. When can this guy be less than 0? No big deal, guys. We already saw that. Okay, from here, when we use a negative number, we saw, oh, it was less than 0. So when, let me use when. Amazing. Okay. It is just amazing. Okay. So 8.1, we saw arc length, but let's just still say a little bit about arc length here. And we really just want to study a theorem. That's the thing. So if we have a curve, if a curve C is described by the parametric equations x equals f of t, y equals g of t, and t is between these guys. If these guys are continuous on this interval, and this theorem should make our life easy, guys. So this is just the statement of the theorem because I wanted you guys to, see where it's emanating from. Okay, so if the f of alpha is A and f of beta is B, now here we want, now what does this guy mean? This guy actually means the curve is transversed only once. Just, turn around just once. I mean, it reaches just once. Let me spell that correctly. Transversed, something like this. Transversed, sorry about that. Yes, we have the right word now. Once. Okay, then if this happens when you have a situation where the curve is traversed once, then the length of the curve is given by the formula so this is the main formula we just want to use, but of course we need to know where it is coming from. It's coming from the fact that you have a curve that is traversed once. So I'm just going to do just one example on this, and that's it, guys. Okay. Example. Find the arc length of the curve x equals r cosine of theta, y equals r sine of theta, and then you have the so-called alpha between and the beta. You have this interval. Okay, don't freak out about the interval, guys. It's nothing. Okay. Solution. Okay, so you see we need the dx dt, right? In this case now, these are thetas, right? So I just have to stick to dx d theta. Differentiate x with respect to theta. You have a negative r sine theta. What about differentiate y with respect to theta? You have r cosine of theta. But what is my formula? My formula is L equals integral from alpha to beta dx d theta all squared plus dy d theta all squared d theta. Now, do we know dx d theta and dy d theta? Yes. But we don't know the values of alpha and beta. We just know they are between 0 and 2 pi. So let's still keep them the way they are. They are just constants. This is going to be negative r sine theta all squared plus r cosine theta all squared. Of course, d theta. Where can I go from here? So this is alpha, beta, r squared sine squared theta plus r squared cosine squared theta. What do you guys think? Don't you think we can simplify stuffs? Yes, we can. R squared, this is sine squared theta plus cosine squared theta, d theta. Alpha to beta, r squared. Now, what is sine squared theta plus cosine squared theta? That's just 1. Amazing, guys. Easy, easy stuff. Square root of r squared is just r, d theta. R is a constant, okay? So let me state that r is bigger than 0, okay? So if that's the case, r is a constant, so you just have like r, theta, alpha, and beta. Okay, so suppose alpha and beta is a number, right? So if alpha is, let's take, say pi over 2, and let's take beta to be pi. What happens? That means that my R beta minus alpha is just going to be, suppose, let's give R a number as well. Let's take R to be 3. Now we have 3. This is a pi minus pi over 2. 3 times pi over 2. What do you get, guys? 3 pi over 2. So when you have a question, of this matter, you can use this arc length formula. Okay. So yes, I'm not spending so much time on arc length because we already studied arc length in 8.1. Okay. So far, guys, we have looked at tangents to parametric curves. We looked at the idea of horizontal tangents, vertical tangents. We've looked at second derivative test for concave up and concave down. And we've looked at, for what values of t do I have my CU, which is concave up? What values of t do I have my CD, which is concave down? I hope this all makes sense, guys. All right.